Oh, it's a sleepy day today. Okay, I hope you are taking advantage of the practice problems after you do your My Math Lab in the packet. So we will have a continuation of notes today for 3.4, and then we'll finish the 3.4 in class tomorrow, and then start preparing for the test that is on Monday. So hopefully, you know, you're getting more acclimated to polynomial functions, finding solutions, etc. We are going to continue on with another theorem that will prove to be very useful in helping to determine what potential roots are. So we'll wait one more minute. Well, there's the bell. So let me submit my attendance and get started. Okay. So the first theorem that I want to talk about today, and perhaps the only theorem we will talk about today, time permitting, is what is known as the rational root theorem. So again, we see notation, we may get a little bit nervous by the notation, but once you get acclimated to it, perhaps, you know, it's not as intimidating. So we have a polynomial function. Whoops. We saw that before when we were defining what a polynomial function is. So again, our coefficients are integer values. And if we're given a polynomial, on the test you will be given a polynomial and you'll have to solve. You'll have to find all the solutions and therefore be able to determine all the roots and therefore the x-intercepts, and then graph it and explain the end behavior. And all the critical values of the graph of the polynomial. So if you're given a polynomial, how on earth are you going to determine what some possible roots are before you actually start factoring and trying to solve for the polynomial? Perhaps you need to know what some potential roots are. An easy way to get the set of possible roots, to find the set of possible roots, you are going to look at all of the P's over Q's. So what are P and what are Q? P are all the factors of the constant term. So if you look at, if it's in standard form and you look at the constant and you think of all the factors of that constant, that is going to give you all the possible numerators, all the possible P's. Then you're going to look at Q and you're going to, well, what is Q? Q are all the factors of the leading coefficient. So I can create a set of all possible roots that I could then either substitute into the function and see if I get a remainder of 0, or use synthetic division and see if I get a remainder of 0 to determine which, in fact, are the roots. So the rational root theorem, or the rational zero theorem, is going to tell you the set of possible rational roots. It will not tell you anything about complex roots, but it will give you a set of possible rational roots. So let's go ahead and look at an example. So here you've been given a function, a polynomial function. I see it's in standard form. And to determine the set of possible roots, I'm going to look at all of the factors of P over all of the factors of Q. Okay, so that means if I am looking at P over Q, I am looking at the set of all possible roots. So I have to look at the positive and the negative values of each of these factors. Well, P is 3. So P is 3, Q is 2. P is the constant, Q is the leading coefficient. So if I think about all of the possible factors of 3, what would they be? Well, they would be plus or minus 1 and plus or minus 3. If I look at all the factors of Q, they would be plus or minus 1 and plus or minus 2. So if I were to look at the set of all possible roots, it would be plus or minus 1 plus or minus 1/2, right? So 1 over 1, 1 over 1/2, plus or minus 3 over 1, or 3, and plus or minus 3 over 2. So all of the potential roots, if I were to write them in order, would technically be -3/2, negative, well, I would start with -3. Start with -3. -3, -3/2, -1, -1/2, 1/2, 1, 3/2, 3. Those are all of the possible roots. Before I move forward, you need to let me know if this makes sense.
It does.
Okay, excellent. Thank you, Amelia.
Dr. P.
Yes, Josh.
So, Q is always the leading coefficient and P is always the constant?
Absolutely.
Okay.
So once you identify P and Q, those values, once I identify P to be 3, I'm looking at all the factors of P. Once I identify Q, which is 2, I'm looking at all the factors of 2. And then I have to take all the combinations. So I have to take 1 over 1, 1 over 2, 3 over 1, 3 over 2. That's how I'm getting each of these. And then I have to separate my plus or minus, because when I write sets, I know I write my sets in ascending order, so smallest to largest, and not repeating any values. So this is going to give me the set of all possible rational roots. Well, looking at this function, what is the degree of that polynomial function?
Three.
Yeah.
So how many roots should I have?
3.
3, and they may not be 3 unique roots, but I should have 3 roots. Well, look how many I have been given here as possible roots. So that means out of that set, I have to see which of these is an actual root. To do that, I would either use substitution for each of these values, or I would use synthetic division. Now, which one you try first? I don't know, maybe you have a gut feeling. If you don't, you have to try them all and see which one is an actual root, because there's only possible 3. Okay, so let's look at another example. Here, you are not asked to just find all the possible roots. You are being asked to find the roots. So in the first part of this, that's the same polynomial, if you notice. That is the same as this. So the first step was to find the possible roots. Now from that set, we actually have to find the roots. Now you said the degree was 3. So that means I have 3 roots. Well, look how many possible ones I have to choose to start with. Now, again, I don't care if you use substitution or if you use synthetic division. Perhaps synthetic division will allow you to continue the process, so I always opt for that, but a quick check is to just use substitution. So let's recall, these are our possible roots. So I need to test each root. Well, I don't know which one you would start with. I personally like to start with 1 because that's a nice, easy number to do synthetic division on. So I'm going to take this and I'm going to do synthetic division. And I'm going to choose for starters x equal 1. It doesn't matter what you start with. Bring the first number down, multiply, right? Add, multiply, add, multiply, add. So in this case, I actually chose my root correctly. If I had gotten a non-zero value as my remainder, it would not be a root. I'd have to throw it out of the set. I know it's not a root. So in this case, I did get a remainder of 0. So I know that 1 is a root. 1 is a solution. So I know x equal 1 is a solution. I'm supposed to have 3. if they're unique, but I have 1. Now, remember, this was the exponent for x cubed, so this becomes the exponent for x squared. So what does this give me? This gives me 2x squared plus 5x minus 3. I now need to solve that. Now, this is a quadratic equation, so I could try to factor it, or I could use the quadratic formula. Now, let's practice factoring because that's a good skill to have. And let's go ahead and factor this quadratic trinomial. What would the two factors be?
Uh, 2x minus 1 and then x plus 3.
Fantastic. Thank you, Miles. That's absolutely correct. Is that Miles? Sounded like Miles.
Yeah.
Okay. So from here, I could solve each of these linear equations, and I could get x to equal 1/2 from the first one and x to equal -3 from the second one. So now I have all of my 3 roots. So the question was, use the rational root theorem to find the set of possible roots, and then go one step further in this case and find me the roots. Now, technically, we could do a lot more with this. We could talk about the end behavior, the tails, right? Can you tell me about the tails? Did we graph this one yesterday? I can't remember if we did it in this class. Did we graph it?
No.
Let's do it then. Let's graph it. Okay. Looking at the polynomial, what can you tell me about the tails?
Left tail goes down, right tail
Both
goes
of
up.
them.
Okay, the left tail goes down. Why on earth would you say the left tail? Okay, where are we starting? What's the first thing that we can tell? I'm looking. From this, what do I know?
I was just going to say the constant term.
Oh.
Or the coefficient, that's
The
what I meant.
coefficient. Okay, so since the coefficient is 2, more importantly, it's positive, what do I know?
The right tail goes up.
Okay, and then based on what do I know what the left tail does?
The degree is 3.
Okay, and since that's odd, the left tail
Goes down.
Goes
goes
down.
in the opposite direction. Okay, so I know the end behavior, I know the roots, I can graph this. Okay, so I'm going to plot my solutions. I know x equal 1 is a solution. Well, let me make that 1/2. Let me make this 1, and then let me make this -3. Right, I know these solutions based on this. Now, I also know the multiplicity of each of those solutions. What is the multiplicity of each of these solutions?
1.
1. 1. Okay, so I know I'm passing through the x-axis at each of these values. So I know the right tail goes up, and I know I pass through it. I know I'm going to have to come, I don't know how far down I'm going. This is a sketch. I don't know. Now, do I know anything else if I were to try to graph this? Like, I'm approaching something very important. What important thing am I approaching?
Y-intercept.
I am approaching the y-intercept. And what is the y-intercept?
3.
0, 3, right? So I could come over here to 3, and I know I'm coming up here, right? And then we said I'm going down here for the left tail. Now, this is a sketch. All sorts of crazy things could be happening here. And, you know, I can't really tell you. This is a sketch, though. So what am I looking for on the test? I'm looking for that you know the right tail goes up, the left tail goes down. I know we're passing through the x-axis at each of those roots because the multiplicity is 1. I can see the y-intercept. So this is a good sketch of the graph. This works fine for me. Now, if I were to ask you to write this polynomial in factored form, so what form is this? I gave it to you in what form?
Standard.
Standard?
form.
That is standard form. So if I give you a polynomial in standard form, you should be able to do all this. But then once I have these roots, I have the corresponding factors by the factor theorem. So what are the corresponding factors? Well, I know if I wanted to write this polynomial in factored form, I have from here, x minus 1. From here, I have 2x minus 1. And from here, I have x plus 3. So there it is in factored form. So if I ask you to write the polynomial in factored form, you should be able to go through this process. Yes? All right, let's try another one. Let's look at this one. You're given a polynomial. You're asked to find the roots. The first thing you have to do is find the list of potential roots, the possible rational roots. So let's look at the polynomial and let's talk a little bit about the polynomial. What is the degree of the polynomial?
3.
So that means I have 3 roots. Okay, can you tell me a little bit about the graph if I were to graph it with respect to the end behavior? What does the right tail do?
It goes down.
Okay, and the left tail?
It goes up.
Excellent. Okay, so we keep that in the back of our heads. So now let's look at the possible set of roots. What is P?
-12.
Technically negative 12, but eventually we'll look at the factors, so it doesn't matter because we're looking at positive and negative. What's Q?
-10.
Okay, so now I'm looking at all the possible factors of P and Q. So let's look at that. So factors of P, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Do you see where I got those numbers? P is the constant. The factors of 12 are there. Now I'm looking at Q. What is Q? Q is -10. So what are all the possible factors of Q?
±1, ±2, ±5, and ±10.
Beautiful. Now, that is going to allow us to write the set of all possible roots. So I have to look at all of the combinations. So I'm going to just write the plus or minus 1 there to not be redundant at this point. I have 1. So I'm going 1, 1/2, 1/5, 1/10. 1, 1/2, 1/5, 1/10. Then I do 2. 2 over 1 is just 2. 2 over 2 is 1. I already have it. 2/5. 2/10 is what? 1/5. I already have that. Now I got to do 3. 3 over 1, 3 over 2, 3 over 5, 3 over 10. This is the set of all possible roots. 4 over 1, 4 over 2 is 2. 4 over 5, 4 over 10 reduces to 2/5. I already have that. Then I do 6. 6 over 1. 6 over 2 is 3. I already have that. 6 over 5. 6 over 10. Do I have that? Yes, 4/5.
Yes.
Then I do 12. 12 over 2 is 6. 12 over 5. And 12 over 10. That's my set. That's a lot. That's a lot of possible roots.
We have 12 over 6, do we?
We don't have 12. We have 12 over 10.
Wouldn't that just be 2 though?
That's 6 over 5. We already have that.
And we already have that.
I see.
Right? So this is, and I don't need to repeat these. This is enough. Now, I found my possible set. Now I have to start testing. Now you got to be clever about which ones you want to try, or maybe try the whole numbers, the integers first. There's really no shortcut as to where to start. I like to start with 1 though. My polynomial's in standard form, so I can start doing synthetic division. Oh, I know 1's not a root. How sad, but I can throw it out. Okay, so now I would maybe, so I'm just showing you that you don't always know what they are. You have to just try. Okay, so let's say I try 2. I found one. Okay, so I know a solution. One of my solutions is x equal 2. Now remember, this was the coefficient of x cubed, so this is the coefficient of x squared. I have what? A quadratic function. I can find those last 2 roots. Now, if you can't factor it, what are you going to have to use to find the last 2 roots?
Quadratic equation.
Quadratic formula. Yeah, find me those last 2 roots. Do that now. Let's try to get those values before the bell rings. Find me those last 2 roots. They may be decimals. I'll just tell you that much. They are decimals. Anybody get them? Go round to the nearest 100th place. Anybody? We do remember how to use the quadratic formula. We do have a test on Monday, so I hope we can do this. Did we remember?
Yes, I'm just still solving the arithmetic.
Keep going. Anybody? Nobody.
Do you want it in like a decimal, or do you want like the equation form, I guess? Or the
I'm
complex.
not looking for roots. I'm looking for 2 values of x in this case.
Oh, okay.
Right? So what are the 2 values of x?
I don't know if this is right, but I got negative 1.064
Yes, that is correct. So, yes.
and 0.564.
Yes. There are my 3 roots. Very good. So what we will talk about tomorrow is we'll talk about how we could possibly use the calculator, and you should know this already because we did this for quadratic functions and linear functions, how we would use the calculator to find the roots. In addition, how if it's an even higher degree polynomial, how we could use the calculator in conjunction with synthetic division to find the roots, the solution to the polynomial function, the roots of the graph, and how to write it in factored form and graph it. So we're going to put it all together and then do one more topic. So that's all I have for you today. So we'll finish 3.4 tomorrow in class, and you have lots to do. You have my math lab to keep working on, so I'll see y'all tomorrow.
Thank you.
You're welcome.
Thank you.
You're
Thank you.